Good afternoon. Myself, Dr. C. Vijay Kumar, Associate Professor, Department of Mechatronics Engineering, K.S.Rangasamy College of Technology, Tiruchengood. So, past two modules we have discussed about what are the process of unconventional machining process, what are the process undergone the mechanical energy based non-conventional machining process. Today we discuss about what are the process undergone the electrical energy based non-conventional machining process. First one is we discuss about the electrical discharge machining process. It is the one of the process undergone that electrical energy used as a non-conventional machining process. So it's a principle behind of that electrical discharge machining process. It is also known as spark machining or spark eroding, die sinking, wire burning or wire erosion. This is called as the electrical discharge machining process. It is a metal fabrication process whereby desired shape is obtained by using electrical discharges. Material is removed from the workpiece by a series of rapidly recurring current discharges between two electrodes separated by dielectric liquid and subject to an electric voltage. One of the electrode is called as tool electrode or simply the tool or electrode, while the other is called as the workpiece electrode. One is the tool electrode, another one is the workpiece electrode. Both the things act as a electrode. So one is the tool, another one is a workpiece. The electrical terminal is connected to one terminal is connected as a workpiece, the another one terminal is connected to the positive terminal is connected to the workpiece, negative terminal connected to the tool. The process depends upon the tool and workpiece not making a physical contact. All the non-conventional machining process is a non-contact type. You see, this is the entire structure of electrical discharge machining process. The bottom one is a dielectric storage tank. The dielectric fluid is sucked from the tank to workplace by using pump, filter, through pressure gauge. How much pressure is allowed to go for that electric fluid from the tank to workplace. That's desired by pressure gauge. Okay. The pan is the workpiece container. Workpiece container is a tank. Then the tank having bottom one is a fixture. Then workpiece. Above the workpiece, we maintaining some gap 2 mm or 2 to 3 mm gap. Then above the workpiece, we have fitted into the tool. The tool is fixed on the tool holder. The tool holder is controlled by servo controlled mechanism. Servo controlled mechanism is act upon the DC pulse generator. The DC pulse generator is generate the DC pulse. According to the DC pulse, the servo controlled mechanism is direct the tool feed. Tool feed means this depth of the tool is decided by tool feed holder controlled by servo controlled mechanism. Once the switch on the power supply, the positive terminal is connected to the workpiece, the negative terminal connected to the tool holder. We are maintaining the 2 mm gap, then automatically the spark will be generated. That depends upon the spark temperature, the metal will be removed from the workpiece. That is the melting. To melt the workpiece, we remove the unwanted workpiece. Based on the tool shapes and tool movement, we remove the workpiece. Suppose if you move the tool vertically, we get a depth. We get a depth of workpiece up to 5 to 10 mm. Suppose if you move the workpiece horizontally, we facing the workpiece. This is the electrical discharge machining process. The electrical discharge machining process, we have some special thing. We get a fine finish, surface finish. We get a mirror finish. Surface finish refers to the process for altering metal surface that involves removing, adding, or reshaping. It is measure of the complete structure of product surface that is defined by 3 characteristics of surface: roughness, waviness, and lay. An EDM surface finish is different to one produced by conventional material removal process. The metal removal rate in electrical discharge machining process is one of the earliest non-traditional machining process. EDM process is based on the thermoelectric energy between the workpiece and the electrode. Material removal rate is an important performance measure in the electric discharge machining process. The dielectric fluid used in this machining process, the dielectric liquids are used as electrical insulators in high voltage applications. Examples: transformers, capacitors, high voltage cables and switch gear. They are using this. These serve as a coolant. So next process under the electrical energy, wire cut EDM. Wire cut EDM means wire cut electrical discharge machining process. This wire cut electrical discharge machining process is an electro-thermal production process in which a thin metallic wire along with the deionized water allows the wire to cut through metal by use the heat from the electrical sparks. The same EDM process, but the difference is we are using tool. Here we are using, instead of tool, we are using one wire. The wire acts as a tool. The wire is usually made up of brass or stratified copper, and the size in between 0.02 to 0.33 mm in diameter. It's a very thin wire. Wire diameter of 0.5 to 0.25 mm. The wire is connected to the negative terminal. There in EDM, tool is connected to the negative terminal, but in wire cut EDM, wire is connected to the negative terminal, workpiece is connected to the positive terminal of the DC power supply. Once energized the supply, the spark is created between the wire and the workpiece. Automatically the spark is created there, the metal is automatically removed. The dielectric is calculated to the storage of tank at high pressure pump. The spark can be generated due to current flowing from wire and the process is done. You see, this is the entire setup of wire cut EDM. The brown color is the workpiece. In between we are inserting the wire. The top we are having wire supply wheel. The bottom means wire take-up wheel. This is the wire supply rod. This is the wire take-up rod. The process is continuously doing. Once the power supply is energized, this place we are having arc. The high temperature arc will remove the unwanted workpiece from the unwanted material from the workpiece. Then automatically we are make a process whether the groove is cutting or completely separating two pieces. Single piece is converted into two pieces, or otherwise we having a single cut or double cut, then easily possible to cut the wire cut EDM process. Then advantages of wire cut EDM: creates simple or complex shapes or patterns that would be challenging to produce with the conventional cutting tools. Then CNC controlled cutting patterns can be completed quickly on a wide range of stainless steel alloys with maintaining low range of surface roughness. Then disadvantages: every machining process we have some advantages and disadvantages. The disadvantages of wire cut EDM: the slow rate of metal removal, the additional time and cost used for cutting creating electrodes. Then reproducing the sharp corners on the workpiece is difficult due to electrode wear. These are some advantages and disadvantages of wire cut EDM machining process. The take home points of today's discussion: we are having two types of electrical energy process under the non-conventional machining. One is the electrical discharge machining process, another one is the wire cut EDM. The two processes are same, but the difference is in electrical discharge machining process we are using tool, but wire cut EDM process we are using wire instead of tool, but the terminal connections are same. Negative terminal is connected to the tool, then positive terminal is connected to the workpiece. So thank you for your patient listening. Thank you.